On Tuesday, you have 15 minutes for all 4 parts. It's gotta, you gotta reach a point where you're like, if I really don't know what I'm supposed to do, move on. So, part A. Let's see. Integral from 0 to 20 w prime of t dt. The thing that I was hoping you were all gonna notice and snap to right away is the fundamental theorem of calculus. And Melissa just looked at me like, what did he just say? The fundamental theorem of calculus. Let's try it this way. What does W represent? W. W represents one thing. It represents
the change in temperature.
W is the temperature. W prime represents the change. It's how fast. We haven't had this conversation in a while. How fast the temperature changes. Fabricio, what does that integral mean then? If W prime is how fast the temperature changes, that integral has to represent one thing. What's the one thing?
How much?
It's how much the temperature changed by. Temp changed by. Well, how am I going to figure that out? If you remember the fundamental theorem of calculus, I have to do what? I have to find the antiderivative of W prime, which everybody knows is, this is W, and then I evaluate from 0 to 20. So it's W of 20 minus W of 0. W of 20, 71. W of 0, 55. And I think you all know how I feel about 71 minus 55.
16.
I don't care that it's 16. I don't even want you to know that it's 16. Some of you don't know that it's 16. Alejandro, why do I feel so strongly about this?
Because it could be 71 and 55, and you can put right there it's units, degree Fahrenheit.
Okay, there was something deeper than that. Salma,
Is it because you don't have to simplify?
you were on the free response portion of the exam. 71 minus 55, you're going to get the full point. For those of you that mistakenly say it's 26 versus 16. Yes, it is 16. Okay, 16 degrees Fahrenheit, yes. And what does it mean? It's how much, let's be really specific here. It's how much the temperature what? I heard 2 things out there. I heard increase and I heard changed. One of them is stronger than the other one.
Increase.
When you just say change, it could be increase or it could be decrease. Jasmine, what did the water temperature do?
It was increasing.
It increased. So how much the temperature increased from T equals 0 to T equals 20. If you got the 16 degrees Fahrenheit, 1 point. If you got the how much the temperature increased by from T equals 0, 2 points. Did any of the groups get 2 points? How many guys got 1 point? Okay, well that's already getting closer to the average. 2 more minutes, show me what you can do with part B. And Salma, I resisted the temptation to start yelling and screaming when I heard you say,
Isn't it 120 on the quadratic?
Yes. That was her. You're like,
and here's why you're not
So we started 0, right?
Raising the Riemann.
well, also because you have non-regression in calculus. It's when you like plug in all the points in the table, or you say like a line that has a bit, or like a quadratic. You would do a quadratic regression if you knew. This problem was quadratic. Like no point.
I never responded to something like that too.
So there's some good stuff out there. I am a happy papa when it comes to the left endpoint method. I do want to say something really important though. At no point have they said equal width.
Okay.
No point did they say equal width. If they had, you would be doomed. Because for those of you assuming equal width, you're thinking like 0, 5, 10, 15, 20,
Yes.
and they haven't told you what the temperature is at 5, what the temperature is at 10. Don't make any assumptions.
What do we have to divide this by?
Pues tell me, there's only 4 supplementary. So we need to
Is it
Am I seeing the four? I'm on my way.
We cannot make any assumptions about equal width here because they didn't tell you that.
So it would be wrong if we assume equal width.
You couldn't do anything with the problem if you assume equal width. Because if you go with equal width, you're going to think that the cut points are 0, 5, 10, 15, and 20. What's the temperature at 5? That's the problem.
for
But it's free response, so they can just leave it at W5.
No. It also means you completely don't understand the question.
Okay.
Okay, I'm not trying to be rude.
No.
Okay, so the key here is we've got to figure out what's the integral from 0 to 20 of W T dt. And I know you guys are really good when it comes to Riemann sums. All I have to do is ask 2 questions. How wide is the rectangle? How tall? How wide? How wide for the first one?
4.
5.
Whoa. Whoa. Look at the data points.
How high is it?
Width.
There's no equal.
Here's the point 0,
It's 4.
55. Here's the point 4, 57.1. How wide? How wide from this point over to this point? 4. How tall?
55.
It has to be 55 because we're using the left endpoint method. 4 is the width, 55 is the height. Alejandro, tell me about the second rectangle. How wide, how tall?
It's gonna be 5 width.
5 for the width. How tall?
And 57 height.
57.1.
0.1.
Thank you very much. Okay, so we've got 4 times 55 and 5 times 57.1. And Jessica, tell me about that third rectangle.
6,
6, and how tall?
61.8.
61.8. And Claudia, tell me about that last rectangle. We've got the first one, the second one, the third one. That last one is 5. 5 times 67.9. Now here's my fear. Some of you are already typing this into your calculator. Cynthia.
And don't you need to use the 1 over 20?
You have to make sure that you're multiplying this by 1 over 20. Why? Because they said to. The significance of multiplying by the 1 over 20? What's the significance? What are you finding?
Average.
You're finding the average temperature. Salma.
What if you just plug all of that in and divide it by 20?
That would be okay. What if you just move on?
That'd be even better.
Oh, you can?
What if we just move on?
We can do that.
Because? You don't have to simplify. It's the free response part of the exam.
Oh, we have to add units to that? Or like no?
Go back and
no
read the
unit.
question. Go back and read the question. Are they asking for units?
No. They're asking if
Asking
it's
for overestimate and underestimate.
All they want to know is overestimate or underestimate. Tell me, give me just a second. Is everybody okay getting here? Okay, you have to be really careful. If you write the equal sign, you're saying these are equal, and they are. Big mistakes from last year, I don't even want you to write them down. Big mistake number 1. What's the mistake? Alejandro, what's the mistake here?
They completely ignored the 1 over 20.
They're completely ignoring the fact that you're supposed to multiply by 1 over 20. Here's mistake number 2. What's the mistake? What's the mistake? It scares me that there are only 3 people in the room that know what the mistake is. Ava, what's the mistake?
Didn't you already solve for the area, so you don't need the
this computation here is giving you the area, don't write that integral again. That means something completely different and, oh my God, wrong. So then the last question is overestimate or underestimate? How many guys are going for overestimate? How many guys are going for underestimate? How many guys have no idea? Be honest. Please be honest. Thank you. What's the thing? What are the things that we know? Salma, what do you know?
It's increasing.
I'm sorry, what?
The function is increasing.
The function, be specific. What's increasing? Be specific. Which function?
W of t.
W of t is increasing. Brown.
The tangent lines for the underestimate are further up.
That you'd have to know about concavity. You know W is increasing. It's only ever increasing. And we're using the left endpoint method. So what? Doesn't it have to be underestimate? Right? Your graph has to do something like that. So I'd say W of t is increasing and we are using the left endpoint method. And so for those of you that like to go on and then say, because the rectangles are not touching the curve, there's area that I'm missing, no one actually cares. The function is increasing, left endpoint method, therefore our answer is underestimate. Yeah.
If it had been decreasing, then it would be the opposite, right?
If the function had been decreasing, right, maybe you need to do a quick little sketch in your head and you're like, oh, there it is. Left endpoint method is now overestimate. Everybody okay? 2 minutes, part C. Now we get to the other bit of Abel, how do you feel about driving my laptop? That sounds good to me.
Wait, right now or
Yeah, now we're I'm sorry, I'm a bit teased to let you work with him. Oh, Claudia. Remind me. Today's Friday. All right, if I could stop all the good work that's happening. I walked around, I've surveyed the class. Nobody's earning the points yet. Jessica is close. Jessica is close. What are we looking for? No, what are we looking for? I want the temperature of the water. When?
At T equals 25.
At T equals 25. I need the temperature of the water at time 25. They've given me W prime. Why, oh why, would they tell me how fast the temperature of the water is changing if what I need is to know what is the temperature at time 25? You can just leave it on my desk. Why, oh why, would they ask you a question about what is the temperature and then give you information on how fast the temperature is changing? They are setting you up for something that I was hoping a whole lot of you were going to notice and snap to here. Brianna, what's the thing that they're asking about? Yes, you're gonna have to use an antiderivative, and I'm seeing on a lot of papers, go and find the antiderivative. My fear is a lot of you don't know why you're finding the antiderivative right now. Jasmine?
I thought it was part of the fundamental calculus, the bottom one, like right there.
The fundamental theorem of calculus is what you need. The fundamental theorem of calculus says the final value equals
The initial value.
the initial plus the total change. Most popular wrong thing I'm seeing right now is that w of 25 equals w of 0 plus the integral from 0 to 25 w prime of t dt. What's wrong with that? 2 people, 3 people, 4 people, 5, 6, 7. What's wrong with that? W of 25 equals w of 0 plus the integral from 0 to 25. Josue, what's wrong with this?
The initial value is not 0
Why not?
because in C it says the initial value is from 20 to 30.
Right? They've told you in the beginning that this guy here, w prime, only works from 20 to 30. Now you had your integral going from 20 to 30. Do you know why we're going to 25? Okay. They want to know the temperature at time 25. So you're going to take the temperature that you know, which is what's the temperature at time 20. Temperature at 25 equals the temperature at 20 plus the definite integral from 20 to 25, not to 30. Final equals initial plus the total change. Is everybody okay from here? Okay, so we'll finish it off. 71, and this is where you can do the work for me. I've already typed w prime into the calculator as F1. I would like to remind you all that this is the calculator active part of the test. Oh, you're the one. Oh my gosh, all the teenage brain power that was spent last year on things like trying to do integration by substitution. Why, oh why, Melissa, are you not going to try to do integration by substitution here? What is it that you know?
Calculator active.
This is a calculator active question, friends. No one wants to see you integrate this function. The Calculus BC students would not be able to integrate this function. I would not be able to integrate this function. Don't try to integrate it. All I care about is type it into the calculator. Correctly type it into the calculator. Get rid of this F1 of 20 because F1 is W prime. Right, and what do you really need there? Just 71. Now hit enter, 73.043.
Oh, I didn't.
9.479.
Wait, so
Okay, now there's a whole other level of freaking out that's going through my head right now. All I need you guys to do is type this into your calculator and have the calculator do all the work. Yeah.
well, adding 71 just definitely integral part, what it doing on 2.043.
If so, you're saying you didn't do the 71, you just evaluated the definite
I haven't
integral.
added the 71.
Right, and so then you would add it, and you're going to then get 73.043 degrees. Please make sure you were able to get 73.043, Brianna.
Do we have to like simplify it?
What?
Or we could just keep it as 71?
Oh, so like you got the decimal answer here of the 2.043 and said 71 plus that? Trust your instincts. Is that okay? Absolutely. Because we know that that is 73.043. Is everybody getting 73.043 in the calculator?
Is it a squiggly line or equal to?
A squiggly line, or is it equal to? Trust your instincts here.
Squiggly.
Squiggly because?
No, it's equal to.
Look on your calculator. I bet you have more numbers after the decimal point, which means that this is going to be an approximation. Did anybody not get 73.043? You didn't get 73.043? Okay, well everybody finishes up part D. Stay where you are. Let me talk to anybody who's not getting 73.043.
0.4x cosine 0.006x. Can you check what mode you're in?
Somebody put your calculator in degree mode. It has to be in radian mode. Anybody else off the 73.1? What did you type in for F2X? Can you check what mode you're in?
Do you need like the table? Yeah. With the endpoints
I don't know if it's for
Yeah. Okay, I think you know the answer to that question. You know, my God, no. You may have noticed every single day that you've been with me, there's a big stop sign on the door that says, make sure your calculator's in radian mode. Brianna.
You're looking for me?
Yes. Brianna. Abel. Jessica. Alejandro. Janae. Melissa.
Oh. United States. Germany.
Giselle. All right, I hope everybody was expecting something like Part D. Part D, the question is, when does the temperature have, is it absolute max?
Maximum.
Absolute maximum temperature. What's the process? What's the process? What are we gonna do? Only 2 people. I'm a little worried. I'm a lot worried. Cynthia, what are we gonna do?
I think we need to do the table.
Okay, we're gonna make that table. Tell me more about this table.
And then it's the endpoints, I think.
Okay, we need endpoints. What are the endpoints?
20 and 30.
Okay, we have endpoints at 20 and 30. So this is like the t value, right? I'm curious about the endpoints, but then in this column, what do I need?
No.
Okay, I think I'm asking that question badly. What we're trying to maximize is the temperature of the water.
That's it.
So the 20 and the 30 are the endpoints. So you find the endpoints, and you need to find the candidate. And so when it comes to the candidate, if you're thinking, oh, WT has an absolute max, and I think this is the part that a lot of you guys still aren't 100% sure of. When I say candidate, what does that really mean? What it means is, I heard it, relative max. W of t has a relative max. Oh, W has a relative max. Okay, so W prime makes a change, and that changes from positive to negative. Abel, can you switch over to the graph? So you've got to figure out what is W prime, when does W prime change from positive to negative? According to Abel, it looks like this is happening at 26.180. Make sure you are getting that 26.180. That's your candidate. Thanks, Abel. So 20 and 30 are important because those are endpoints. 26.180 is important because it is the candidate for a max. Endpoints, candidate, next thing. You need to plug in correctly though. You're trying to figure out the temperature of the water. So you're going to ask the question, what's the temperature of the water at 20?
71.
What's the temperature of the water at 20?
71.
71 degrees. Okay, Miguel, you're frozen for a little bit. What's the temperature of the water at 30? temperature of the water at 30. Abel, what are you gonna do?
Would you could do, well, you already did like 71 plus the integral from 20 to 30,
71 plus the integral from 20 to 30.
and then W prime of t.
W prime of t, right? We just did the fundamental theorem of calculus. The temperature at time 30 is going to be the temperature at time 20 plus how much the temperature changed. So then same thing down here, 71 plus the integral from 0 to this 26.180 W prime of t dt. And now it's just a matter of finishing off the computations. And so Abel, if you wouldn't mind doing that. The only thing we really needed from the graph was the root, was to find that candidate, and maybe you did the store feature, which is my favorite thing. We're going to say this 26.180 is A or it's D for your favorite math teacher. And then we're just going to 71, that wasn't funny. Okay, 71 plus the integral 20 to 30, f1 of x dx, according to my friend back there, 72.193. Cynthia.
For this, why is it the second one going from 0 to 26.180?
Oh my God. Thank you. Thank you. Right, you're going to have to go from 20 because 71 is the temperature at time 20. Thank you for making me a better math teacher. Yes, ma'am.
We have to put 71 because we started like that, right? So that's how we know what's the maximum. It's always easy.
You have to start at 20 because W prime that function only works from 20 to 30.
And it's not asking to change that. That's why. You know what I mean?
No, I don't know what you mean.
Okay, so it says when this is the temperature of the water, we see maximum temperature, not how much it has changed. That's what we need to put 71 plus the.
No, the reason for the 71 is that W prime, which is the rate function here, tells you how fast. I only get to start using this function at time 20. That's why 20. Okay. And what do we get for the final value? 73.127 degrees Fahrenheit. For all the friends that weren't getting the numbers before in the calculator, are they working now?
Yeah.
God, why do you lie to me so much? All right, so the answer to the question, when is the temperature going to be max? At T equals 26.180. If the question is, what is the maximum temperature? 73.127. If the question is, round your answer to the nearest degree Fahrenheit, you're going to say 73 degrees Fahrenheit. Done. Okay. All right, we got about 10 minutes left, which is perfect. Let's talk about the homework this weekend. We can turn this